Hello, what's going on everyone? This is Oscar and today we're working another problem from Calculus 3. This problem is asking us to compute the work done by a force along this path r of t. We're given I, j, and k values for r of t and where t is from 0 to 1. So for these problems where you're computing force, you're going to want to follow a general formula. This is the general formula. It's F written in terms of r of t, and then you dot product with the derivative of r of t. Let's just first jot down the original function. So our f of x, y of z is equal to, written in vector form, we can write this as 4x, 7y, and negative z. And then we could write down our original r of t function that's given to us. And this is equal to t squared, t to the third. So if we want to find f in terms of r of t, the best way to explain this is here's our x, y, and z values here. So this would be x, y, and z. And then for each term over here, you're just going to want to plug in the corresponding values. So our f written in terms of r of t would just be equal to 4 times, let me make this neater for you guys, if this is in vector form. So our x value is just t, so it'd just be 4t. And then here we have 7, and then 7y, and our y value is just t squared, so it'd be 7t squared. And then comma, over here we have negative z, and our z value is just t to the third, so this would be negative t to the third. Okay, and now we do, as you could tell from our formula, we want to do r prime of t. So here we have r prime of t would just be the derivative of each component. So t, derivative of t is just 1. The second one would be 2t. And then the last would be 3t squared. So we would want to do the dot product here. So it'd be our f r of t. Here it is. And then we do the dot product with our r prime, which is just 2t, 3t squared. Okay, so here we'd have to do dot product, which means you multiply each corresponding, as you can see we have x, y, and z values, and then you add them up. So if we solve this, it'd be 4t plus, and then if we do y values, this would be 14t cubed minus, here we have negative 3t, and then if we do 3 to the power of 3 times 3 cubed, this would be 3 to the 5th power. Yes, that's correct. Okay, now let me give you guys some space so we could work this problem out. I'll delete this. Okay, so now that we have this figured out, what we're actually going to do here is take the integral from what's given to us from 0 to t. So it'd be 0 to 1, and this would be dt. So we integrate this, and we should get the work done by the force. So if we do the first integral, it'd be 4t squared over 2 plus 14t to the power of 4 over 4 minus 3t to the 6 over 6 from 0 to 1. If we keep solving, this 4 over 2 is just 2t squared plus 14 over 4 t to the 4th minus 3 over 6 is just 1/2 t to the 6th from 0 to 1. Since we're integrating by t's, we're going to want to plug in first 1, and then we plug in 0. Uh, if you see 0 would just be 0 if you plug in 0 for all of these. So we're just plugging in 1. So it'd be 2. We plug in 1 here, it'd be 1 squared, so it'd just be 2 plus, the same goes here, 1 to the power 4 is just 1. This is 14 over 4 minus t to the 6. 1 to the 6 is just 1, so minus 1/2. Simplifying here, we could actually do this on the calculator. We have 2 plus 14 over 4 minus 1/2. Our final answer here and the work done would just be 5 as our final answer. For this question, you basically just have to memorize how to write f in terms of r of t, and then also how to take the derivative when given r of t by itself. I hope this helped, and good luck solving more math problems.